Welcome to This Explainer. Today, we're diving straight into a breaking cosmic paradox recently illuminated by the James Webb Space Telescope. We're looking at a celestial object that sounds like two completely contradictory ideas mashed together and asked to somehow, cooperate. Can a black hole be a star? It's a truly wild question. We usually think of stars as these glorious sources of radiant light, actively pushing energy outward, right? And on the flip side, we think of black holes as the ultimate cosmic drains, dark, light-trapping voids, pulling everything inward. So what happens when you attempt to combine them into one object? It sounds a bit like building a lighthouse around a locked cupboard and expecting the cupboard to somehow power the lamp. But as we're about to see, this is a very real, incredibly serious scientific proposition that's literally reshaping our understanding of the cosmos. Astronomers from a survey, appropriately named Mirage or Miracle, by the way, just spotted an extremely bright red dot in the deep early universe. They cataloged this discovery as Mom BH Star 1. And get this, we're seeing its light from a time when the universe was merely 660 million years old. That is just about 5% of its current age. Finding something this massive in the cosmic dawn completely defies our conventional understanding of astrophysics. It's basically acting like a missing bridge between the very first, primitive gas clouds and the massive, fully formed galaxies we see today. To really grasp the sheer scale of this anomaly, just think about this number, 100 billion. This newly found object is outputting roughly 100 billion times more energy than our sun. That is a staggering level of brightness that no ordinary star can physically produce through normal means. If a normal star even tried to generate this much energy via standard nuclear fusion, physics simply wouldn't allow it. It would be so incredibly massive that it would instantly blow itself apart. Yet, here is Mom Beach Star, shining with the power of 100 billion suns, appearing as a compact, incredibly red point of light. So, what is actually going on here? Lead author Rohan Naidu from the MIT Kavli Institute provides the key insight that unlocks this mystery. As he notes, our picture of this object is evolving rapidly. We aren't looking at a standard star at all. Instead, we're likely looking at a nascent black hole, boasting roughly 100,000 times the mass of our sun, buried deep inside a massive, incredibly dense envelope of hydrogen gas.
Section 1. Inside a black hole star.
Sometimes called a quasi-star, a black hole star does not have a traditional nuclear core at its center. Instead, it's a giant star-like atmosphere built entirely around a feeding or accreting black hole engine. The black hole itself is the power source, while that thick surrounding gas acts like a stellar envelope, trapping and filtering the intense energy being generated at the core. There's a delicate, wildly violent balancing act happening inside this object to keep it stable. First, matter is continuously falling into the deep gravitational well of the central black hole. As that infalling gas spirals downward, it heats up tremendously due to extreme friction and collisions, pushing intense radiation outward. This outward radiation pressure acts like a shield, pushing back against the incoming gas and preventing gravity from immediately crushing the entire giant structure. Because the surrounding hydrogen envelope is so massive and thick, it absorbs this high-energy radiation and re-radiates it outward, making the whole object shine brilliantly like an impossibly large star. It's literally a cosmic stalemate between the crushing force of gravity and the explosive force of radiation. To put that physical structure into perspective, the outer envelope of this object is unfathomably huge. If you were to replace our sun with a black hole star, its outer atmosphere wouldn't just swallow Earth. It would extend up to 1,000 astronomical units into space. That is way beyond the distant orbits of Neptune or Pluto. We're talking about an object the size of an entire solar system, with a tiny, incredibly dense black hole engine at the very center, operating as a single unified star.
Section 2. Normal stars versus quasi-stars.
There is a fundamental difference in the engines driving these celestial bodies. Normal stars, like our sun, maintain a stable balance by slowly fusing light elements like hydrogen and helium in their cores. It's a relatively slow, steady, reliable process. Quasi-stars, on the other hand, are violently powered by an accretion disk feeding a black hole. The material spiraling into the black hole is subjected to such extreme forces that it actually converts a much larger fraction of its sheer physical matter into pure energy than nuclear fusion ever could. It is an incredibly efficient but highly, highly volatile power source. And because of this hyper-efficient, aggressive engine, their lifespans are drastically different. A normal star can shine brightly for billions, sometimes even trillions of years. But a black hole star, it's essentially consuming its own structural support to survive. As the black hole mercilessly eats its own surrounding envelope, it grows rapidly, and that delicate balance between gravity and radiation pressure eventually fails. These cosmic beasts vanished in the absolute blink of a cosmic eye, lasting only about 7 to 10 million years. To put that in perspective, dinosaurs roamed the Earth for over 150 million years. These objects lived incredibly fast, died young, and left behind massive black holes. Section 3. Solving a Deep Space Mystery. Since the James Webb Space Telescope began observing the deep universe, astronomers have been completely puzzled by hundreds of mysterious anomalies they refer to as little red dots. They seem to be absolutely everywhere in the early universe, but they essentially disappear by the present day. Researchers have been investigating these deep space images, desperately trying to untangle their true identity. Are they densely packed early galaxies full of normal stars, or are they hiding massive, overgrown black holes? Well, MOMBH1 actually provides the missing clue to answer this question. It features what astronomers call an extreme Balmer break. This is a massive, sudden drop in light at specific wavelengths caused by dense hydrogen absorbing the energy. Because this drop is so incredibly deep, it completely rules out ordinary stars. It proves that this extremely red color is not just cosmic dust, as astronomers might normally assume, but rather a massive screen of thick hydrogen gas hiding something much more powerful inside. So why does all this matter? These black hole stars likely solve multiple mysteries at once. Not only do they offer a working template for what those hundreds of little red dots actually are, proving that dense gas can redden light without dust, but they also provide a protected growth stage for early black holes. By feeding rapidly within a massive, dense envelope, these quasi-stars acted as the very seeds that eventually became the supermassive black holes anchoring massive galaxies like our own Milky Way today. They perfectly explain how giant black holes could exist so astonishingly soon after the Big Bang, a puzzle that has challenged cosmologists for decades. As we wrap up, we're left to marvel at how an object that sounds completely impossible, a star literally powered by a black hole, might actually be a crucial stepping stone in the history and formation of our universe. And honestly, it makes you wonder, if the James Webb Space Telescope can find a black hole star lurking in the cosmic dawn, what other impossible cosmic monsters are hiding in the dark, waiting to be illuminated next?